That's my least favorite question in general. So let me answer you. The fact is, I get asked that question all the time, and people who do fundamental research in physics or chemistry or whatever, you get asked that kind of question all the time. And the problem with it is that we don't look for gravitational waves or for magnetic monopoles or for violations in CP violation or whatever it is to make a widget or to make some application. It isn't why we do fundamental physics. But it turns out that compared to people, so it's for knowledge and for understanding more about nature, it's what makes us better than animals as humans. We have curiosity and we try to understand what this world is we live in. And we have a couple of features that make us a little bit smarter, but make us different than animals. One is that humans are the only animal, I think, that understands mortality. Not understands it, recognizes that it exists. We don't understand it, we grapple with it. And the other is that we try to satisfy our curiosity, and not curiosity about how to get some more food or something, but just curiosity itself. And that's why we do what I do, and it's curiosity-driven research. However, it justifies itself and is worth the investment beyond the fact that humans should do it anyway, because that's what we're good at and what we like to do, because sometimes it does pay off in ways. And just in my own personal experience, I've seen two fundamental experiments that at the time they were done and the time they got accolades as scientists, nobody had any idea they had any application, because you often don't know for many years after. The first was an experiment in Berkeley. I was in Berkeley, and that experiment was done, I think, then in the late 50s or around 1960, and it tested another idea of Einstein's called stimulated emission. And so this is a fundamental prediction of Einstein's stimulated emission. It was proven or seen in an experiment in Berkeley. A Nobel Prize was given for it, and nobody had any idea that at that point that it was useful for anything. It was more than a decade after the discovery that people started recognizing that the fact that this produced focus beams was useful, and now it's a huge industry, which is the laser. Okay? But nobody knew the laser at that point. So that's, to me, okay, he didn't do it for that. If you asked him the question, he wouldn't have said it wasn't used. Second one is I was doing an experiment on an electron machine, I mentioned that, at Cornell, and in particle physics. And down the hall was a guy I was friendly with who did a nuclear physics experiment that proved a principle in nuclear physics called nuclear magnetic resonance, which if you ever studied physics, you probably saw. He won a Nobel Prize. Nobody thought it had any, he certainly didn't think it had any value, other than that it was a very important principle for nuclear physics, and I think a justifiable Nobel Prize. And now it is the most important imaging device we have in medicine. Of course, they've subtracted the word nuclear because we're allergic to using that word in anything medical, and it's called magnetic resonance imaging, MRI. But it was basically from a fundamental physics experiment. So the right question is fundamental physics experiments like the one I do of value to humanity beyond their intellectual value? And the answer is, on the average, yes. But some are, because we're not doing it for that purpose, some will pay off and some won't pay off. I have no idea about gravitational waves. The tendency is to think it's too weak of an effect to matter for anything, but that would be presumptuous for me to really make that conclusion.